than some polynomial divided by some other polynomial. Oops. All right. What happens now is that we're going to have different degree polynomials. And within all these different degrees with the functions themselves, there's going to be different rules. And there's a whole slew of them. But as you go through them a couple of times, it becomes really, really, really easy to do. Now, what I decided to do, well, before I do that, one of the things I wanted to talk about to start with is to remind you guys what is domain and range. All right, x's and y's. Which one's which?
Domain is x, range is y.
They're not even. No, not it.
So your domain is your all possible values of x, and your range is the all possible values of y. So one of the things the way that I always remembered it, since it's x and y, domain and range, what comes first in the alphabet? Domain or range? Domain. Therefore, what comes first, x or y? X. Domain goes with x, range goes with y.
Or you can think about it like cowboy ranchers. They start at the domain. That's where they start. That's first. And then they go to the range.
Where the deer and the antelope play. Oh, be a home.
You know, I really don't like when we sing in this chorus.
So let's talk about all the junk then. Let's talk about all the junk.
Oh, yes.
Now, don't even bother trying to write that out because I just made a copy of it.
I'll find it.
You're supposed to be in there. You just made it.
Now you gotta make me get up.
Or this
Now, what I want to do is, the book again likes to the book tends to be a little overcomplicated on some things. Go figure, it's a math textbook. What I want to do is reword this in easier terms, in ways that'll make it a little bit more sense. Okay? So right off the bat, what I want you to see here, this is just polynomial divided by some other polynomial. What they're doing here with these, this whole slew of stuff here, that just means the polynomial is written in descending order. That's all that means. Okay? It's written with a descending order where m, let me move this around a little bit here, I'll put that on the board here, where m is the degree of the numerator, the value of m is the degree of the numerator, n is the degree of the denominator. The values of a and b, they're just a leading term coefficient. Yeah. The values of a and b you see here, it's just what's the leading term coefficient of the polynomial. That's it. Okay. That's all it is. Once you see a couple of quick examples here, you'll see how very easy it is to identify it, to identify the parts out. Yeah.
Why are some of the letters subscript and other ones are?
Don't worry about it. It's just going down in degrees and placements and stuff like that. That's all it is. The a sub n is the first term. A sub n minus 1 is the second term coefficient. A sub n minus 3 is the third term, and so on. Just remember that that's the way to write it for descending order. So what happens then is that you're going to be able to figure out specific parts, and that's where these three rules come into play. The first one are the x-intercepts. The x-intercepts will always be zeros of the numerator. Basically, it's factoring and find your zeros. The vertical asymptotes will always be the zeros of the denominator, because you can't divide by 0. You've been doing that. That's not a big deal. And then the last part is talking about the possible ways of showing horizontal asymptotes. And when we're showing horizontal asymptotes, there's 3 different scenarios. And that's where the degrees come into play. Whether the top is the same as the bottom, the top is bigger than the bottom, or the top is smaller than the bottom. That's where this looks. And you guys have already worked with the ones when they were equal. You did that last week. Because you did this problem. You did this where you had to graph f of x was 3x minus 2 over 2x plus 1. You told me that the horizontal asymptote was at 3 halves. Because what's the degree of the top? 1. What's the degree of the bottom? Aren't they the same? You were already doing that. What's going to happen today is that this is going to be an 11th degree over a first degree, and then you have to follow these other rules. It's very, very easy to do. It's not going to be 11th degree, okay?
Does this follow the same, they can't go in the asymptote areas?
Kinda. There's a little bit of variance within that, because it's saying that at most, depending upon the function, it could jump some stuff around. So asymptotes are asymptote-ish for some problems, but it's going to be very easy to tell how this works.
Okay.
So let me just jump right into an example. Okay, let's look at this. I'm going to walk through all the steps that you'll have to do with these things, and like I said, after you do it a couple times, it's really quite simple. So I have y equals x squared plus 4x minus 5 all over x minus 6. And what we're going to do is we're going to do some rough sketch of the graph. So in order to do a rough sketch of the graph, I got to plot an x and a y grid just to start. Right. We know that we'll have vertical asymptotes at the zeros of the denominator. So what's the 0 of the denominator here? 6. So I know that I can start out by writing vertical asymptote at x equals 6. I plot it. Just like that. I know that's going to occur. We all right with that? Okay. I also know that I'll have x-intercepts. My x-intercepts are going to occur at the zeros of the numerator. Well, that just means I have to factor it. So what times what is negative 5? But you add together, you get positive 4.
4 and negative 1.
5 and negative 1, too. So your zeros would be at negative 5 and 1. So I know I have intercepts at 1 and negative 5. So far, so good? I just know I'm going to have x-intercepts there. Now I check the degrees. The degree of the top, the m value, is 2. The degree of the denominator is 1. Is m bigger than n, or is m smaller than n, or is n equal to n? Bigger. So according to my sheet here, if m is greater, do I have horizontal asymptotes? No. No horizontal asymptote. Okay? Now what do you think I'm going to do? Put it on top of it. M and n, they're the degrees of the m, remember, it's the degree of the numerator. N is the degree of the denominator. So I'm going to go to my calculator. Hey, it's convenient that I had it in there. I believe your window is probably at a negative 10 by 10. So if I go to look at the graph, I get something like that, if you're at a 10 by 10 window, right? Okay. Now, that's only giving us is it possible there could be something else going on the other side of the asymptote? Yeah. How could you tell what it is? Change the window, or even easier. Oh, what's wrong? You got it okay? Oh, okay. What I want you to do before you start messing around with your window, go to your table. If you go to your table, you should see that you have an error at 6. And why do you have an error at 6? It's the asymptote. Okay? So your asymptote is at 6 because you can't divide by 0. But if I go to if I'm on the right hand side of it, see at 7, it's at 72. If I keep scrolling down, at 11, it's at 32. So it's starting way up top here and it's working its way down. So I know that there's something like that happening on the other side. So now, just change your window real quick, just to get an idea. Change your window to an X maximum, I don't know, 100. And a Y maximum of 100. You might get a better view of what's going on.
Oh, that's like a big nose. Number nitroform, very uniform,
And you get something a little bit like that. Now, in your graphing calculator, it probably looks a little bit cleaner than what I have up here.
Terrible.
I am a terrible artist, but I'll get over it. What do you think is occurring right here? It's a slant asymptote. You actually do wind up with slant asymptotes with this style. We don't worry about finding the slant asymptotes with polynomial functions in Algebra 2, but you will next year in pre-calc. The only slant, starly face. The only slant asymptotes you had to worry about here were when you had hyperbolas in the conic form. A over B, remember we just walked the box over and found the slopes of those lines? Next year, you'll actually get into this and finding those. It's a little bit different with the polynomials. It's not bad.
I'm curious, how much like algebra is pre-calc?
A lot. A lot. Yeah, to be honest with you guys, Algebra 2, first semester Algebra 2 is about, no, it's a lot of review of Algebra, first semester of pre-calc is a lot of review of Algebra 2, but taking it an extra step. One extra step.
Because that's what we're doing. This is like algebra, but one extra step.
Pretty much.
Is it kind of too?
Go figure, math builds on prior knowledge.
I never would have guessed. Honestly,
Maybe that's why I'm bad.
Let's walk through this one then. Oh, I'm sorry.
This is mixed differences.
What's the answer? Like, is there an answer?
What we're looking at doing here is exactly what we just did. We've got a rough sketch of what the graph is going to look like. We identified all possible parts that we know how to find as of now. I'm looking for rough sketches with x-intercepts, asymptotes, and that's really it. Yeah. Yes, ma'am. What part?
Like if you were to move your calculator graph over, first graph over here,
Yeah.
is that the same as the graph on the box?
Yeah. I just. Mine's just an awful hand. I drew it.
It's not like Mr. Murphy's terrible.
I'm terrible.
So like, do you even know the baby flat slant asymptote, or are we just pointing that out?
I'm just pointing that out. Because you should, when you start to see some of these blown up in a different window, you might look like there's something going on. I just wanted to show you that there really is something there. It's just, you'll learn it next year.
Yeah, and then are we still solving for like, so like, are these graphs that we're making, are those the ones that can't happen?
What do you mean, can't happen?
Because like the other day, you said we were solving for the thing that can't happen.
We're solving the
Yeah.
No. Let's walk through this one. It's not that it can't happen, it's just the, oh yeah, that's you can't divide by 0. What's happening is, if you, the value, okay, I remember this conversation now, because you guys overanalyze way too much sometimes.
Tell me something I don't need.
All right. What happens here is these vertical asymptotes create zeros within denominators. If you have 0 for a denominator, it's bad. You can't do that. Okay? So this value of that vertical asymptote is what creates 0 in the denominator. And that last one is when x was equal to 6, you get an asymptote.
That's the only thing.
So, oh yeah, so if I want to think about it, as far as domain and range, because that's where I want to go into now, if I want to talk about the domain of this problem, let me clean this up a little bit. This curve looked like it was 1, 5. It was doing a little bit of this, a little bit of that, I think. Something along those lines?
Yeah.
Okay. Now, starting today, I want us to take these graphs. We've done all the legwork of identifying x-intercepts, which are the zeros of the numerator. We found out their vertical asymptotes, zeros in the denominator. We also decided whether or not there were horizontal asymptotes by playing the game with the degrees of the numerator and denominator. In this case, there were none. So now our next step is just to list out the domain and the range. And when we do this, I want to start using what's called set notation. You guys have seen it before. Domain would be the set. What? It's Jay Leno's face.
You're so funny.
Domain will be the set.
Why is that person so mean? I don't even know her name. She has to be so good. Shut up. It's annoying.
Sorry.
You're annoying me.
It'll be the set of all real numbers. Oops. That's the symbol for all real numbers. Yeah.
Wait, so are we on the first one again? I don't know.
Yeah, going back to write out the domain and range. That R with the extra line through it means all real numbers, such that x doesn't equal 6.
No friendship.
The set of all real numbers such that x doesn't equal 6. Basically, this is where you're going to list your asymptotes. Now, for the range, is there any variance on range? So the range then would just be all real. I would just write it out as all real numbers.
Wait, is that like a symbol?
We have to put this one down. It's just,
Is it just a squiggle?
It's a bracket. It's a
Yeah.
bracket.
it's a weird kind of.
Can I just like
Put it
this?
on. Here, it looks like, when it's actually, it looks like.
Wait, can I?
It's a bracket. Okay, it's all it is. It's just a bracket. Yeah.
So when we're writing the domain and range, it's really all we're
And the next couple that I have got more asymptotes. We'll list out more exclusions, if you will. Okay. Yeah, that straight up and down line means such that. Because there's so many letters. Huh? Not imaginary?
No, what happens like when?
Just roll with it.
What if it's revised? It's okay. Hey,
Let's look at this. I have 3x squared minus 13x plus 10 in the numerator. X squared plus 8 in the denominator. And I'm going to go through the same process of doing rough sketches and plotting out everything that I need to know. So the first thing I want to do, excuse me, actually probably do it on the order that it's on your little sheet there. The first thing they do is always find the zero of the numerator, which means I'm going to factor that. Okay? So what times what is 30, bless you, that you add together to get negative 13? Okay, so you get 3x squared minus 3x minus 10x plus 10. And I'm going to factor that by grouping. Take out the 3x, get x minus 1. Take out the negative 10, x minus 1. Okay. Therefore, you wind up with zeros at 1 and 10/3. Now, some of you guys hate factoring by grouping because it takes a lot of time. If you recall, you just learned another way to factor. Yes.
Well, they have to do 30, right? So why is that 15 negative?
We want to get it to equal 13. But you want negative 1, you want positive 30
Oh,
to negative 15. Or excuse me, negative 13.
Yeah, there.
Okay. Now, could you have done this via synthetic, find a zero?
Yeah, you
Yeah, you can do it. Let's say you started at 1 with 3, negative 13, and 10. And you wound up with that. So this is 3x minus 10 equals 0. Add 10 by it. It works the same way. Some people like to do it that way because it's faster. It's fine. So you have 2 zeros then, so you have 2x intercepts. Add 1. And 10 thirds. Okay.
How do you represent 10
A smidge more than 3. It's a smidge more than 3. Now when I talk about the denominator, I'm looking for the zeros of the denominator. Will I get a real answer here? No. So do I have a vertical asymptote? No. There's no vertical asymptote. Because it's a non-real solution. I'm looking for real solutions for my asymptote. So now I go to the next step. The next step is I look at my degrees. The degrees in this case are the same, squared on both, right? So when they're squared on both, all you do is your asymptote winds up being at the fraction of the coefficients. What's the coefficient of the numerator? Denominator. So it's your horizontal asymptote. And the horizontal asymptote winds up being at y equals 3. Okay. We get the horizontal asymptote since, if I look at the leading term, see how the degrees are the same? When you have the same degrees, your asymptote will be at their coefficients fraction, which is 3 over 1. Let's write it that way. Yeah, and what happens now is this is when you just you pop into your calculator and get a rough sketch idea of it. And excuse me, one of the things that happens, I believe it's this one. It looks funny, yeah. Alpha y equals 3x squared minus 13?
Yeah.
Plus 10 over x squared plus 8.
You had two
No,
equations.
you didn't do the fraction.
Oh. Oh, I didn't. Yeah, you're right.
Whoa, this is weird.
Oop, I gotta change my window. Now here's where things are a little weird. Don't I have values greater than my asymptote? Me too. Here's where if you look at the wording on how it talks about it, it has the possibility of at most one of these happening. It is possible that the asymptote can be labeled, but non-existent. Okay? This is where it is possible that you could have an asymptote at 3. In this case, you don't. It's not a big deal. Okay? That's why they put that little caveat in there about at most. So it's possible you could have it, or it's possible you might not. In this case, it is not cool. I know. It's one of those things. It is just how it sits itself through. Yeah.
Wait, how do you know?
You have to look at the table. If you look at the table, I mean, once you look at the graph, you should recognize that this looks like it's already higher than 3.
So y is higher than 3.
Yeah. Right. So in this case, if you scroll through, you notice that when it's negative, some of the values themselves it gets above 3 there. So this may not hold water, if you will. It's a possibility, but it may not be true. It's one of those weird things. Horizontal asymptotes are weird like that. So you still label it as a possible asymptote. That's their only rule. I just wanted to show you guys that sometimes it doesn't show up.
There's no way from the equation to tell if it's real or not? And do we have to say this right now? Okay.
I just wanted to show you guys that something happens. You're right, you have this little dip like that, and that's okay. It's all right, okay? You guys get involved with a lot of this later on. I'm just showing you the big basic sets. Sir?
Is that the only, because you know, when we have like two different curves or stuff, is that the only curve on the graph?
In this one, yeah.
Okay,
Where I'm going to show you one that has 3 curves in a second.
okay.
Okay.
You do.
You guys can have some.
This one, yeah, this one does. This is where it gets to be the craziest, if you will. This is where it gets to be about the craziest of all the stuff we're going to look at today. Again, all we're doing is listing out the possibles, rough sketching, and going with it. All right. In this case here, start by figuring out your intercepts. We start by doing our intercepts by what times what is negative 10, add to negative 9. Negative 10 and 1. So it becomes 2x squared minus 10x plus 1x minus 5. You factor it by grouping.
Wait, how does that get you? Oh.
So you wind up those set of terms, excuse me, which means you wind up with zeros at 5 and negative 1/2. Very good. So starting our graph, I know I have an x-intercept at 5, and I know I have an x-intercept at negative 1/2. We okay with that? Now I go to find my vertical asymptotes. Vertical asymptotes are at 0 of the denominator. Yes, sir?
Never mind, you're in.
No, what?
No,
No, where are my asymptotes? You're right. Where are they?
is that possible or not?
Yeah, because you're factoring.
4 and negative 4.
Good. Your asymptotes are at plus or minus 4. So your vertical asymptotes here's my x-intercepts, my vertical asymptotes. All right, x equals plus or minus 4. Okay? And now you look for your possible horizontal. Now, in my possible horizontal, notice again you have the same degree on top and bottom. So
Yeah.
where does it go from there? 2.
2.
So we have a horizontal asymptote at y equals 2. Now when you put that in your graphing calculator, you're going to see something pretty funky. Oh, I screwed that up, didn't I? With 2x squared minus 9x.
Minus 5.
Oh, I have it as a plus, that's why.
That looks pretty cool. This is pretty
Is everyone really cool?
That looks like a bowl.
Exactly.
What's that?
What?
You might have done the same thing I did. Yeah, I think you did the same thing I did. I forgot the x. 9x, yes, sir. What's that? Degrees were the same. So it's x squared and x squared. It's just leading term coefficients. So it's 2 over 1. Now, in this case here, you get this funky looking thing where your tails of the graph appear to be following the rules of your asymptote. Your tails are following the rules, but it's that kid in the middle, that middle child syndrome.
Hey, that's not a real thing. Hey, middle child.
You just need to stop.
It's doing that.
That's the root.
And and it's possible. It's totally possible here. Because in the tails, it's partitioning this off to separate parts of the domain. For separate parts of the domain, the range values change. Okay? It's just one of those weird things that happen. So when I label my domain and range on something like this, well, it's the same basic principle. Your domain, set of all reals, such that x doesn't equal what?
-4.
Or? Yeah. Set of all reals, such that x doesn't equal plus or minus 4. And then the range, set of all reals, such that y doesn't equal 2. And we still just listed out more of it. Okay? Yes, ma'am?
So for these, you don't want us to put points on there, you just want us to put
I'm-
it box.
For right now, that's all I'm worried about. We'll worry about all the funkiness later, and how it gets worse. Not really worse, but a lot of times you're looking at your table. You know, it's not like it's anything crazier. You still, what's tough here is just remembering. Over time, it gets easier the more you do it. Like how easy it is to just remember what goes where, and it's not that bad because it's just a matter of labeling. Excuse me. Oh, thank you. Yeah, sorry. Y cannot equal 2. I forgot to slash there. Sorry about that. I think I said it, but I just didn't do it. I did that last hour too. Oh, yes, ma'am.
I have a question. So, like, what in real life, like, do people use asymptotes and like these graphs and stuff for? Like, is there any
Teaching algebra 2.
Principal rate. When you're talking about compounding interest, things like that, there's going to be. You ever heard of the rule of law of diminishing returns? What happens is when you have exponential functions, there's a rate at which it doesn't make sense to do it anymore. And that's where the asymptotes come in. It's a little bit more of an economics finance situation. You'll see more of it, of the actual usage of an asymptote when we get to laws. Because that's when the word problems come out, and it actually makes sense.
Why do you even use the table? I don't get the purpose of the table.
Of the table, just to help you find points. You don't have to do the substitution.
Okay.
And so you don't have to do the work. So if I'm looking at the table here, I don't want to sit here and type in, I don't want to go by hand and put in 0 for x, put in 2 for x, 1 for x. I'm going to hit the button on the calculator to give me an order of pairs.
Oh, okay, so it's just for order pairs.
And a lot of times with this, it helps you see patterns. It'll help you see when things are switching from the x, from the positives to negatives. So sometimes you might be able to identify approximately where a 0 is occurring, between -5 and -4, it jumps from positive to negative, so something happened in there. It's just little things like that. Okay. Also, the table function allows you, if you take your numerator, if you take and type in just the numerator, find your 0, use it to synthetically divide to find the other. It's an awesome trick.
Oh, like 5.
So, do this one. Take a minute, try that one. Label out all the parts, all the fun. This wasn't that bad.
No.
Hopefully you got your x-intercepts would be, let's see, x minus 3, x plus 1, so we'll be at 3, -1. We have vertical asymptote at x equals -4. All right, and then do we have a horizontal asymptote?
No, sir.
The degree is larger than the top is larger than the bottom, so there's no asymptote. Okay. So then we just rough sketch, put in our zeros, put in the asymptote, and I don't remember exactly what this curve looked like, but you might want to move your window around to see what's happening on the other side of the asymptote as well. And it shouldn't be that bad. Looking at itself like that. Is there another curve you just don't see off the other side there? Imagine there would be. If you change your window at all, it probably looks the same, just mirrored image of it. Yeah, so if you just move your window out to your X minimum at -100, Y minimum is 50. Watch it. Okay. So there's a mirrored image of it down here as well. Okay. Domain and range, remember your domain here is all reals except for what?
3 and -1.
-4.
Oh,
Where's your asymptote?
oh, sorry.
And then your range is all real. Okay? Let me give you a few of these to try out for tonight. I've decided that I want to get fancier with this, so we are not going to quiz this stuff tomorrow. There's no point. Do those,
Wait, so there's no quiz at all?
except for
And the
Colton's.
You guys not this week? Oh, yeah, it is. Hey,
Never worry.
Don't forget domain and range, all right?
you just put them at the bottom.
Should be relatively simple. Okay?
Are you gonna give us any homework tomorrow?
He won't do it anyway.
Exactly.
Do my homework on
Oh, I gotta get that.
Because I have no plans, because I have no plans.
I have